OK, so that's what XSS is. Remember that it subverts the same origin policy. Now let's talk about how you actually implement one of these attacks. There's actually two categories of XSS, and there are two different strategies you can get to cause a website to execute your unintended JavaScript, or to serve a web page with your unintended JavaScript for browsers to run. One of them is stored. One of them is reflected. Let's look at each of them. One type of XSS is called stored XSS. And the character of this strategy is that the JavaScript ends up being stored somewhere on the server. And then when browsers ask for the website, the server goes into its database, pulls the malicious JavaScript, and sends it to the browsers. That's why it's called stored or persistent, because it's living on the server somewhere. So the most classic example I can think of, and I always forget the difference between these two, so I use examples to remind myself, stored XSS to me is like a Facebook page. So if you think about Facebook, anybody can make posts. And you can imagine if you make a post, what does Facebook do? It probably takes the content of your post and stores it somewhere on their server. And then when someone else loads your profile, then Facebook goes into the database, grabs all of the posts that you've made, forms an HTML page, and sends it back to the user who requested it. So your posts are being stored persistently in Facebook's database. So what that means is maybe an attacker, instead of posting their cat picture or posting a meme, they instead write some malicious JavaScript and they press post on their Facebook page. Well, now that malicious JavaScript is stored on Facebook servers forever, and anyone who wants to access the attacker's Facebook page will load the attacker's Facebook page, and that JavaScript will get pulled and served to the browser. And if Facebook isn't careful and doesn't implement defenses, then anyone who loads that page will see JavaScript. And critically, it's not just any JavaScript. It's JavaScript that has the origin of Facebook. So it can access all of Facebook's secrets or tamper with the appearance of the Facebook page. So that's called stored XSS. And the problem here, again, is a server-side problem. It's Facebook not doing its job defending. And we'll see that when we see defenses. But this is the first type of XSS attack. And I think of it like storing posts on a social media website. So here's a picture of stored XSS. There's three computers on the web that we care about. There is a victim, there is an attacker, and then there's some server. Here it's bank. Previously, it was Facebook. So the first thing the attacker does is it sends some malicious JavaScript to the bank.com or facebook.com server. And now it's stored forever on the bank.com server. So some JavaScript is now living here, written by the attacker. Now when the victim requests some content, the bank will pull that malicious script potentially. Like if you're loading the attacker's profile page, it will retrieve that malicious JavaScript from its database and send it back to the victim. And from the victim's perspective, that JavaScript has the origin of bank.com. It can control all of bank.com's web page that is returned. And then that JavaScript runs in the victim's browser because XSS is browser side. JavaScript is browser side. OK, and I guess what can XSS do? For example, it could steal valuable data. So maybe one thing it could do, instead of just saying alert1, which is boring, maybe it will say steal the cookie and send it over to the attacker. That's something that JavaScript could do. Because it has the origin of bank.com, it can access bank.com's session token, for example. You could also make malicious requests. So maybe that JavaScript makes a malicious request and says, I want to send $10 to Mallory. That's also something that could happen.